Hello and welcome everybody. At this point, we've gone over several different components in the hydraulic part of the braking system, and now we're going to start tying things together. The majority of the brake lines on a vehicle are going to be preformed, bent, rigid line that's going to be anchored to the chassis of the vehicle. The only part where we want flexible line is between moving components like the wheels that steer the axles by the wheel cylinders to connect some of those moving components with the suspension back to the chassis. And if possible, just route only rigid line between the different components mounted to the chassis. Brake line has to be resistive to corrosion. So instead of just having a steel line, it has to be coated in something. So usually there's like a zinc or some other type of plating on the outside of a steel line, much like this one. And this comes in a roll, and these are just sections removed from that roll and cut and straightened out. This line can be bent and formed with the use of a tubing bender to route it to the areas where it needs to go and fit snug against the different contours and around different areas that it needs to be routed. The other type that's acceptable to use is nickel copper alloy. So the nickel with the copper gives it strength so it can withstand the pressures that it needs to withstand. The nice thing about the nickel copper or the NiCop brake line, it's a little more expensive, not by a whole lot though, and it is much easier to form by hand. If you have to tweak something and straighten it out, you can do so pretty easily by hand. You can massage and move and bend and straighten out the steel line, but it is harder. The other part where it comes into play is when you are forming flared ends. And we're going to get to how to do this here in a moment. There's two different types of flares. This example here is a double flare or an SAE. Here's a close-up of a double flare or an SAE flare. And that is formed by taking the cut end, dressing the tip a little bit with a file or with a reamer, and then it flares out, and then it is folded back in on itself to create the angle that is needed to seal on the coupler or whatever component that it's mounting to. The other type of flare is a bubble flare or an ISO. Here's a close-up of an ISO or bubble flare. So the ISO flare is a bubble flare, and it just crimps out and then back in a little bit, and this is the shape of the end of that tubing. And then when it seals along these surfaces. Now what's missing from this line is what's called a flare nut. So a flare nut is straight thread, just like a bleeder, just like a normal fastener. So it is a straight thread, and in the center it's hollow. Flare nut butts up to the back side of that flare, and it's what pushes and what cinches that connection together. So as this is threaded into the component and the line seats against the sealing surface on the component, the flare nut is tightened down, and then that actually crushes that sealing surface together, and it creates a nice clean seal without any issues. Why do we call these banjo bolts? Banjo bolts have the hole on the side and the hole down the center and carries fluid through the bolt into a component. And these usually join between a flexible or hard line and whatever component is being actuated with hydraulic pressure. The name banjo bolt comes from this type of fitting on the end of a line. And right there you can see the hole where that opens up to where the bolt goes through. Now around this fitting, there is a relief that's molded into the end of this. You can see it a little better right there. That allows fluid to go around the bolt. When the bolt is passing through, we have one hole, or actually this one has two holes on it. When the bolt passes through the banjo fitting, fluid goes around the bolt and enters those holes. So with this in place, we have fluid that is able to go from this line running perpendicular to the bolt, and the fluid is passing all the way around this portion of the banjo bolt. It's called a banjo bolt because this can resemble somewhat of a banjo. Here's another example of a banjo fitting. Doesn't look as much like a banjo, but the idea is the same. In order to seal a banjo fitting, we need what are called sealing washers. And these washers are made out of softer material like aluminum or copper. Here's an example of a copper sealing washer that has been used, and it has been crushed a little bit. As we tighten these down and crush the sealing washers, a lot of times these fittings will have grooves to help lock that profile in place and prevent this from leaking. If these aren't tight enough, they will leak fluid. Here's our banjo bolt. The bolt has a seat around the base of the head, and that seat is going to clamp down on that sealing washer. This is going to go through the banjo fitting with our sealing washer in place underneath the head of the bolt. On this side, we will need another sealing washer. When this is fastened to the component, as we tighten the bolt, it's going to crush both sealing washers and provide an adequate hydraulic seal, and fluid can then pass from the line, through the banjo fitting, and through the banjo bolt. Part of our visual inspection on the brake system is going to include areas like this, where we have a hard line that has a permanent crimp fitting to a flexible line. Flexible lines are used to get to places that are articulating, like on the suspension or the steering. This allows the line to be flexible and move with the suspension component while still holding the specifications for the pressure that it is supposed to withstand in the system. On the other end, there are fittings for the lines to connect to either rigid line, flexible line, or to another component. These can be made out of rubber. They can be made out of braided stainless steel. Here's an example of a bracket where this would mount to a component and help route the line to where it doesn't get caught into something like a moving wheel, a rotating wheel or tire, and that keeps it out of the way. This is off of a 1986 Nissan 720, and the customer concern was a spongy pedal. Now, upon inspection of the condition of these lines, over here where the hose is crimped to the banjo fitting, it has started to become brittle. And as the cracks form, they will worsen, and we can see where the inner lining is becoming exposed. The concern with this one being a spongy pedal was resolved by replacing these lines. The reason why that fixed it was under pressure. That fluid pressure was causing this to bulge, and rather than having hydraulic pressure go to the brakes, the hydraulic pressure went to the hose, allowing the pedal to sink farther than it's supposed to. So the driver felt like the pedal was soft or spongy, almost like having air in the system. So visually inspecting our flexible hoses for wear like this is something that we can spot and resolve before there is a customer concern of having inadequate braking abilities. Or some other reason, if these lines get pinched, is another reason they might need to be replaced. So we're going to take this and trim it down to a section, bend it to form around a portion of frame rail, and flare the ends so they connect to a component. Our first step is to remove a section of line from the coil. We're going to use this tubing cutter. It has a sharp wheel right here that's going to gradually depress into the surface of the line. And there are two rollers that are going to hold the line steady and allow that wheel to make its pass. As we spin this around, we can gradually tighten this a little bit more and more, and that's going to help that wheel, that cutting wheel, move farther and farther into the tubing. This is done by rotating it around, and continue to work the cutter around until you feel that resistance give way and you know your cutter is passing into the material. And there it is. You can see on the end of the tubing, it's not very smooth. It has some burrs on it from the cutter pressing into it and leaving a bit of material sticking out. The next step is to dress the end of the tubing so when we make our flare, we don't have extra material or burrs interfering with the finished product. This is what's called a reamer. We have an internal reamer on this side, and these are hardened carbide cutting surfaces. And the same thing on the other side, but this is for the external. I'm going to use a piece of emery cloth here to take off some of those major parts. And use the reamer I'm not giving it much pressure. I'm lightly applying pressure as I spin it around the reamer both directions. The first example for forming the flare is going to be the ISO flare, or the bubble flare. The first thing we need to do before we form the flare is to install our flare nut. Once we form the flare nut cannot be put on. This is our ISO or bubble flare kit. There are a couple different designs of tooling to do this. I'll show you one example. In the kit, we have instructions with diagrams. We have a few different dies for different size tubings and pieces to help flare that end. This is going to be our forming tool. We're going to remove these pieces and mount the forming tool in the vise. Our forming tool is mounted into the vise. It's going to offer a sturdy platform to help flare that end of the tool. Step 1. Clamp the flaring tool body into the vise as shown in Figure 1, which we've done. Step 2. Select the correct collet and forming mandrel for the tubing to be flared. See the chart at the right. Here we've selected our correct collet and the forming mandrel for the ISO bubble flare from this kit. Step 3. Insert the proper forming mandrel into the tool body as shown in Figure 1. While holding the forming mandrel in place with your finger, thread in the forcing screw until it makes contact and begins to move the forming mandrel. When contact is made, turn the forcing screw back one complete turn. See Figure 2. threading it in until we feel it push on that forming mandrel, and we feel it touch the end of it there. You can barely feel that. So now I'm going to back it out one complete turn. Step 4. Insert the prepared brake line tube into the correct collet and slide the clamping nut over the collet. Insert assembly into the tool body. Use our flare nut out of the way. Now this needs to be tightened to keep that line from pushing out of the tool. Step 5. Wrench tighten the clamping nut into the tool body. We just did that. Step 6. Wrench tighten the forcing screw until it bottoms out. Do not over-tighten the forcing screw. If you do over-tighten, the flare may become oversized. Then, step 7 says back the clamping nut out of the tool body and disassemble the clamping nut and call it assembly. The flare is now ready to use. And that is how you make an ISO or bubble flare. Line nut is on there, ready to tighten it into the component. The flare nut has threads on it. We're going to use a flare nut wrench to tighten this into the component, and the flare nut is going to support the load of tightening this fitting together. These threads do not seal anything. These threads help push this end into its sealing surface, the mating surface on the other component. The first part of forming a double flare is to push the material outward, so that we can then fold it back in on itself with our finished product. Before forming the flare, we're going to put our flare nut onto the line. Threads facing the end that's going to be flared. Next, we take our forming die for the first step of the process and make sure that fits inside of the tubing. Then we mount the tubing into the tool. And this will be positioned just up to the first shoulder of the forming die. Once our height is set, we can tighten our wing nuts and clamp the line in place. Now we fit the forming tool with the peg into the line to maintain that internal diameter. Then we take the next piece of our tool, slide it around here, and bring it over the forming die. And get that just snug by hand. It will rotate and bottom out against the body of the forming tool here. Then we have our T handle that we're going to slide through the tool. And we're going to tighten this down. We're waiting to feel for the resistance to change from a nice steady even pressure and feel for that resistance to increase as we form the end of that line. Right there, the resistance went up. Now we can back the tool off. And we are at the first stage of creating that double flare. Now we need to fold that outside flare back in on itself to create a double wall, double flare. For that part, we use the same forming tool, this time without the forming die. Again, we're going to tighten until we feel resistance increase and not force it too far. That's about it right there. Then we remove our line from the tool. And that is how you make a double flare fitting. Now that we have our line prepped and formed for fitting onto the system on one end, this is when you would bend the line to fit whatever contours of the frame or the area that it needs to replace the rigid line. For this, we use a forming tool. This is just one variation of it. And this has different diameters on it for different size tubing. What this does is it maintains the round shape of the tubing without kinking it, and as it engages, it forms a bend. Some of them have degree marks. And then when you're ready, you can form your bend. We'll do a 90-degree bend. And there's our bend. Rotate it 90 degrees, and then do another bend. With one 90-degree bend, it's hard to get a nice tight fit, snug around a section of frame or the chassis because we have a radius. So this doesn't mount flush with that. But by doing two different 90-degree bends, we can fit this snug against one face and also against another face. So this is a good way to form a 90-degree fit around a frame rail without the line coming off too far in one direction or another. This would be clamped and anchored in place to keep it vibration free, and it may have to be insulated with rubber on the mounts. When working with flare nuts and rigid tubing and brake lines, this goes the same for any formed line, whether it's the brake system or another system on the vehicle. These can strip. Using an open-end wrench is not advisable. It's easier to round the corners of the hex shape on the flare nut because you're only driving on two surfaces. The wrenches that we use for these types of fittings are flare nut wrenches. They come around the very end of the corners here, so we're driving on as much surface area as possible. And with this open end, we can fit it around the line and engage it onto our flare nut. So this maximizes the amount of drive surface that we have on the flare nut without potentially rounding the corners. To avoid cross-threading our fastener on our flare nut, try to get the thread started with the line loose. Make sure there's some wiggle there. We're now connected, and then we can bring it in finger tight, and then we can position our line where we need to put it, depending on our application. Then, use our flare nut wrench, come around the line, engage onto the flare nut, and help support the line where we want it to stay so it doesn't turn with the flare nut. And as we tighten the flare nut, we want to snug it down. Now our line is mounted nice and sturdy to our component. I hope you were able to gain something from this topic today. When fabricating lines, they may need to be fabricated for a number of reasons, whether that's for corrosion or for other types of damage to the brake lines. Remember, if a line gets kinked, its internal diameter is then restricted, and we don't have even pressure going throughout the system, and it becomes unbalanced. So even a kinked line will be cause for replacing the line and fabricating a new piece if you cannot find a factory replacement prefabricated, pre-bent piece of line. Do a thorough visual inspection of the system. Look for any indications of leaks or damage to the lines that are rigid lines or the flexible lines that go to moving components. Always use a flare nut wrench to loosen and tighten flare nut fittings. Always put your flare nut on the line before you fabricate the end into the type of flare that's needed for the system. This has been Brake Lines and Hoses. Thank you very much.